Okay, that's how bad it
She
was
just
tonight.
rolled around on the floor. That's
Exactly like I would have. Okay. When it comes to breakdancing, I have broken things before. Okay. So just so you know. All right, ladies and gentlemen, if you would take out your packet. Okay. Take out this packet that we started working on yesterday. Okay. Abby, why are you shaking your head at me? Abby, look, we can be honest with each other. We're building relationships here. If I'm embarrassing you, just please tell me, let me know, okay? It is. It is. It's a good way to start the end of the week. It's a good way to start the end of the week. And if you missed these, ladies and gentlemen, or want to relive them, the video will be out there on YouTube later today.
Really? So like this entire video with what I've been saying is going to be in there?
Well, I started it just a few minutes ago, but a good majority of it, yes. Okay. Yes. So
I was saying some pretty important
you were. You were. That's why I like to start the video early and get it going. See? Okay? All right. So where's Theodore today?
What'd you do in class today, Cameron? You want to talk about vape tricks?
Yeah. Great. You know, that really isn't smart because they could probably use that against me to fire me if they wanted to. But anyway, ladies and gentlemen, I don't have that many years left anyhow. Kevin, Sam, Zach, good. Jules, Aiden, and Alicio. Okay, I'm just double checking on the pronunciation, trying to get your names down. Okay, so we got Abby, Itzel, Elsa, and Shamante is still not here. Whoop, Shamante is not in the class anymore. Okay, that kind of makes some sense. I don't know. All right, so we got. They don't tell me. People just magically vanish from my seating chart, and that's supposed to mean they're not here anymore. Cameron, Evelyn, Finn. Is it Finley? Sorry. Okay, I have another student, Finn, who I never mind. Anyway, Adriana. Okay, Ray, Karina, Giselle, right?
Yeah.
Okay, and Shining. Why is it the shortest person hides in the back? Why? You should be up in the front. Can you even see?
Yeah.
Okay. All right. Albert, Estefani, Skylar, and Adriana. Correct? Okay, thanks. Somebody's at the... Hey, wait a minute. This is kind of funny. Theodore is at the door.
What the freak?
Theodore.
That's a good one.
Okay, sign in. Just on there. It doesn't work on that anymore. When you're late, you can't sign in on SmartPass like you used to. Okay? Again, they're working on things for us with this. Anyway, ladies and gentlemen, welcome to Thursday, your last day of the week. I won't point out again that it's not my last day of the week, so you guys get a 4-day weekend, but I don't, but that's okay. I'm not bitter about it at all. As long as we're talking about things, ladies and gentlemen, we are going to have a quiz next week, Wednesday.
Second day back.
Oh my gosh, no. You had 4 days this week and 2 days next week. That's your 6th day back. Okay? You won't forget everything by then. If you do, you'll fail the quiz and start out with an F, and then you'll have to work your way up. It's okay. Life goes on. Okay? But what will be on the quiz? Your vocabulary? Hey, guess what? 6 out of the 20 points is to define chemistry. Okay? 6 out of 20. That's 30% of your test is on a definition that you should have written at the top of your yellow sheet. Okay? I am letting you know. And then, along with that vocabulary, also things like hypothesis, control, constant, experiment, things like that. And then, ladies and gentlemen, measurements. Knowing the instruments, knowing what kind of measurement they take, knowing what unit goes with them. The 7 base units. Okay? Questions? Good. As long as we're talking about that, name me an instrument used in science and tell me what kind of measurement it takes. Any instrument used in science.
Instrument.
Yeah. Do you want an example? What? Okay, good. A microscope is an instrument used in science, but do we use it to make a measurement? No. So again, it is an instrument that's used in science, but I want something that is used to make a measurement. Think about measurements that you've made in other science classes. What instrument did you use to make them?
Ruler.
A ruler, okay? Every science class, they give you a ruler or a meter stick and they ask you to measure something. What does it measure?
Like the length, like
Good.
inches or like centimeters.
Okay, but that's all what? One word.
Distance.
Thank you. All distance. So ruler measures distance. Good. Give me another instrument.
Ammeter measures electric current.
Good. Have you ever worked with an ammeter though?
No, I haven't.
Okay, but that's fine. That is one that is, and that's one that I gave you in the presentation the other day. An ammeter is an instrument used to measure what again?
Electric current.
Electric current. Yes, thank you. Scott.
Scale for weight.
Scale for weight, and I'm going to correct you just a little bit. Technically in science, sorry, I get technical once in a while. What?
Mass.
Mass, and technically it's not a scale, it's a keeping two things at the same.
Balance.
It's a balance, okay? Again, it is a little bit touchy of me to say that, but there is a difference between a scale and a balance. We're not going to get into it now, but again, the choice on your quiz or on your test would be balance, not scale, just so we know, okay? Good, give me another one. Hurry, I don't have all day here. Whoa! For use to take what? Time. Good. Good. Is it hot in here or is it just me?
A thermometer.
Good! What does it measure?
Oh, temperature.
Temperature. What else? There's a bunch in the cabinet over there.
Oh, those little glasses, like
Those little
the
glasses.
the
Okay, she's going to say the tube glasses. When you finished high school,
graduated cylinder.
there you go. My gosh, you guys are good this morning. Okay, what does graduated cylinder measure? What? The volume. Very good. By the way, graduated cylinders do it. What else could do it? What? Close. In science, we call it what? No. Starts with a B, ends with an eker.
Beaker.
Beaker. Very good. Very good. Very good. Okay. All of those things are instruments, ladies and gentlemen. All of those things take measurement. Now, again, you could get into talking about also a light meter to measure candelas, things like that. But I'm talking about instruments that you've used before. You've used beakers, you've used graduated cylinders, you've used thermometers, you've used rulers, things like that. Okay? So that's good. Questions? All right. Awesome. So what I'd like to do today is I'd like to begin giving you some time to work on that metric conversion worksheet. So that's why I asked you to take it out. Now, someone asked me this morning about what I would and wouldn't give you on a quiz if I give you a question like convert this from this unit into another unit. I am not expecting you to memorize all of the conversion. You don't even have to write them down on your periodic table. Don't waste the space on them. If we're going to do a problem where I'm going to ask you to convert from one unit to another, I am going to give you the conversions that you would need right now. Okay? So I will give you that. So take out your worksheets from the other day, and we're going to go over something in a minute. But before we do, ladies and gentlemen, I want to show you an example of what I mean by me giving you the information, me asking you to find something. There it is. Okay? So let's say, for example, I give you a problem that says convert from 356 centimeters into decimeters. Okay? So I give you a question and I ask you to go from centimeters to decimeters. Okay? Now, in the question, I will give you these two facts which you need. Number one, 100 centimeters equals 1 meter. And I will also give you that 10 decimeters equals 1 meter. This is a two-step problem. And the reason it is a two-step problem is because this has a prefix with it, centi, and we are going to something that has a prefix with it, deci. If we were going from centimeters to meters, you would only need one step to do it. If we were going from decimeters from meters, you would only need one step. But because we're going from a prefix unit to another prefix unit, it just takes two steps. Okay? Now, the other point that I want to make is these things here. You can put the 100 centimeters on top over 1 meter, or you could put 1 meter over 100 centimeters. It's your choice as to which way you could set it up. It can go either way. What determines that, ladies and gentlemen, is the unit that you are trying to cancel. Okay? So understand this. From this fact, we could write two ways: 100 centimeters over 1 meter, or we could use 1 meter over 100 centimeters. And it doesn't matter because these are equal to each other. So either way, I could put either one on the top, I could put either one on the bottom. And the same is true for this one here. I could do this either way. I could do 10 decimeters over 1 meter, or I could do 1 meter over 10 decimeters. Anytime two things are equal, we could set it up as a fraction and put either part on the top and either part on the bottom. Questions? So we take what we are given to begin with, which is our number here, this 356 centimeters. We're going to copy that down. And now we are going to use a conversion factor, a fraction. Now, I am going to need to use both of these. I know that. But the one I'm going to begin with is the one that involves the unit that I am already in. Since I'm in centimeters, I'm going to use this conversion factor. Okay? And specifically because I'm in centimeters, I need this one down here because it puts centimeters on the bottom where I can cancel it out. Make sense? Okay. So now what I do is I put 1 meter over 100 centimeters. And I have now canceled out the unit of centimeters. Now, if you wanted to, you could stop, grab your calculator, get an answer, write it in meters, and then take that and do the next step because we're still not to decimeters. I don't recommend doing that. In this class, the way I teach things to you is I want you to put things into a calculator one time. One time. So that way you don't accidentally make a mistake of entering a number or things like that. Okay? So if we can make this one step in the calculator, your chances of getting the correct answer, I think, go up dramatically. Okay? Plus, the nice part about calculators nowadays is, at least the ones that I have here, if you make a mistake, you hit the up arrow button and it takes you back into your last calculation, and you could go back and change something if you needed to. Okay? So I'm not going to stop here. I'm going to keep going with one more conversion. And the reason I'm going to go with one more conversion is because now I'm in meters and I want to get into this unit of decimeters. That's why it's a two-step process. So again, I'm going to set up another fraction bar. Now, which one of these two do I use? Well, I originally chose this one because it had centimeters on the bottom, right? Well, now I've got meters up here on the top. So now I'm going to use the one that has meters on the bottom, which is this one here. So I'm going to put 10 decimeters over 1 meter. Okay? And now the unit of meters cancels out. Now I need to just do my math. Okay? I need to just do my math. Okay? Now, how you go about putting it into the calculator is kind of up to you. And to be honest, there are multiple ways that you can put problems into a calculator and get the same answer. And we will talk about those as we get into those. But what I would do if I were you, I'm just going to erase this, move it down a little bit. Okay. This is the way I would put this into your calculator. 356 divided by 100 times 10. I've taken this number. I'm dividing by 100 because it's on the bottom. And then I'm multiplying by 10 because it's on top. Now, you may be sitting there going, well, what about the one here and the one here? I don't care about them. You multiply or divide by 1, it doesn't change anything, correct? So all I'm doing is putting into my calculator what I absolutely need to. If you finish this problem, it should work out to be 35.6. And then our unit, the only one that we haven't crossed off, is decimeters. And that's how you work these problems. That is how you work these problems. Questions? Okay. Now, I do need a favor. Do two of you have calculators, please? Could you please take them out for a second for me? Okay. Both of you, please. Okay. Do you have yours right? Take it out, please. Okay. I'm just going to set up a problem here. I don't know. I got threes on the brain. All right, we're going to go from centimeters to decameters. The two things that you're going to need is 10 centimeters equals 1 meter, and 10 meters equals 1 decameter. Again, I'm giving you these. These are coming. If you're wondering where I'm getting these from, ladies and gentlemen, I'm getting these from here. Okay? So, centimeters to meters, 100 Did I just write down 10? Okay, I'll correct it. Sorry. 100 centimeters equals 1 meter. 10 meters equals 1 decameter. This is where I'm getting these from. I'm going to give them to you in a minute for your worksheet. Okay? Sorry, my bad on here. Okay? My bad on here. Let me correct that. Okay, so if I were to set this up, the first one, I'm going to use this one up here. The 100 centimeters goes on the bottom. The 1 meter goes on the top. Okay? Hang on a second, Abby. Don't go getting too far ahead of me, okay? Then the second one is 1 decameter on the top, 10 meters on the bottom, correct? Okay. So, Abby and Ray, I want you to both put in this, 3.78, and then I want you to hit divided by, okay? Now, Abby, I want you to put in 100 times 10 and then hit equals. Now, why am I doing 100 times 10? Because they're both on the bottom. Okay? Ray, I want you to do this. 3.78 divided by parenthesis 100 times 10. And then I want you to give me an answer. So, Abby, when you put it in just this way, what did you get for an answer?
0.378.
Ray, when you put it in this way, what did you get?
I got 0.00378.
So, which one's right? Right? Nope. Now, you may be going, Mr. Brand, why did you multiply by 10? Well, what I did is I multiplied the two numbers on the bottom together because they're both on the bottom, right? But your calculator is doing what is called orders operation in math. So your calculator, by doing it this way on the top, took 3.78 divided by 100, got an answer in its memory, and then multiplied that by 10. Her number is too big here. Ray, because he put it in parentheses, it said divide this by these two numbers multiplied together. Now, there is another way you could do this in your calculator. You could do this. Okay? Could you do that one once, Abby? And tell me what you get? Now you get the same as Ray's. Now, the point that I'm briefly trying to make here, ladies and gentlemen, is this. There are multiple ways that you may have been taught to do this problem, okay? When I do this and I put this into the calculator, I normally put it in this way. What I mean by that is I will put all the numbers on the top, multiply them all together first, hit divided by, and then put all the numbers on the bottom in. But if you're going to do it that way, you need to put it in parentheses. If you're going to do divided by 100 divided by 10, because they're both on the bottom, that will work out too. You need to figure out how you want to go about doing these problems and putting them into your calculator. Okay? So that's the only thing I'm warning you of. This is correct because you could take 3.78 divided by 100 times 10, but you have to put those two numbers on the bottom in parentheses. When they're on the top and you're multiplying them, you don't have to put them in parentheses. It will just automatically multiply all those things together. But if your numbers are on the bottom, okay, you either need to divide by both or you need to put all of the numbers in parentheses. Again, your choice of how you want to do it. Okay? Questions? Okay, good. Good. By the way, ladies and gentlemen, my biggest thing, last year was the first time I've taught chemistry in a long time. Okay? And the biggest thing that I realized last year was the thing that impeded much success by many of my students was not their chemistry, was their math skills. Okay? In other words, putting things into a calculator, not being able to multiply by 1,000 in your head or divide by 1,000 in your head, those things are going to slow you down. Or I would have students who could work the problem out perfectly, set it up perfectly, but they always made a mistake when they put it into their calculator, so they would get their answer wrong. Now, luckily for you on problems like that, I only count the answer as 1 point. The work you show me counts as points also. So, for example, this problem here, 2 points for the answer. 2 points for the answer, 1 for the correct number, 1 for the correct unit. So half of the problem is right here, half of the points. The other half is your answer. So also I've got people who don't like to show me this stuff and just write down an answer. Okay, I'll give you your 2 points for the answer, but I don't know how you got it. Okay? So keep that in mind. All right. The stuff you need to get going on your assignment for today. All right. No, that's not what I want. Back. That's what I want. All right. We gave you everything you needed to do the first 3 problems, correct? As far as the conversion goes? Talk now or forever hold your peace. Come on. Did I give you everything?
Yeah.
Okay, good. Second page. We did the top one. I gave you the 2 conversions for the second one, correct?
Yes.
Okay. The 2 conversions were 10 decimeters equals 1 meter and 1,000 millimeters equals 1 meter. Okay, so those are the things that I gave you. Zoom. The last one down here, you need this. 1,000 millimeters equals 1 meter. What I'm asking is if you don't have these, copy these down, because in a minute I'm going to flip the page over and give you the other ones. I'm giving you what you need to do the conversions. Then I'm going to give you time to do the conversions. Okay? So please, all I'm asking you to do is copy these down. Don't start working them. If you're done with it, you can wait until I get to the next page. Okay? Questions? Okay, can I flip it over? Or does someone need more time? Okay, here we go. These, on this page, we are going to kilograms. So, 1,000 milligrams equals 1 gram, and 1,000 grams equals 1 kilogram. Okay? Now, because every one of these problems goes to kilograms, ladies and gentlemen, this conversion right here will be in every one of these. Okay? It will be in every one of these. So 1,000 grams equals 1 kilogram can be written in all of these. Now, in H, that is the only one that you need because you're going from grams into kilograms. One-step problem. In I, you are going from centigrams, so you need this. 100 centigrams equals 1 gram. Okay? Sorry, that's an ugly looking C, but that's what that is. And in the last one, 10 grams equals 1 decagram. So these are all the conversions that you need to finish every one of these problems. Jules, you must not have been asleep because Bulkowski just walked straight through. You didn't wake Jules today.
Because Jules wasn't asleep.
I thought Jules was awake, so I didn't feel like I needed to bother her today.
I know, but if you don't interrupt my class in the morning, how am I going to call you Kramer by the end of the year?
It's true.
And the only one who will get that is you and I, probably.
Probably. I did put some pickles in the fridge and I wrote my name on them so you don't steal them.
Okay. I bought a bad jar of pickles, though. That jar doesn't seal.
Oh, the ones.
Yeah, the lid
plastic
just
one?
sits on top. I'm
You
like,
buy that kind. You gotta buy the
I know,
Milwaukee
I
pickles
know,
with
I
the-
know,
you
I
bought
You can't
know.
open them.
He bought the fancy
You
one.
can't open them. So.
Oh, can't open them.
You
Yeah.
can't open them.
No, but that's what I have you guys for. If I get in trouble, I'm going to bring it to you, Jules. You'll just muscle it up.
Forget it. What are we doing today?
Metric conversions.
That sounds terrible.
It is.
Enjoy.
What do you mean it is? What do you mean it is?
I didn't say that.
No one heard you say that. We were all sitting right here. Come on. All right. So on this page, ladies and gentlemen, we are going to decimeters. So on every one of these, 10 decimeters equals 1 meter. You're going to need that on every single one. Okay? Now, because you're going from meters here to decimeters, that's the only thing you need. That's it, just the one step. The second, to go from millimeters to decimeters, we need 1,000 millimeters equals 1 meter. The next one, kilometers, 1,000 meters equals 1 kilometer. And the last one, 100 centimeters equals 1 meter. Okay? So those are all the conversions that you would need. All right? So if I give you a problem on a test, I will give you these things because those are the ones you need. I'm not expecting you to memorize them. Fair enough? All right. So here's what I'm going to do, ladies and gentlemen, because you're probably going to be in different spots. After I'm done with these, there is one more page. After I'm done with these, I would recommend you get with a partner. You start working on these for a little while. Some of the ones on the back are a little bit tricky, so we will save those for a little bit later, okay? But I'm going to give you the ones for these, then you can get to work. Again, we're going to centigrams in all of these, so that is 100 centigrams equals 1 gram for every single one of these. For this one, 1,000 grams equals 1 kilogram. For this one, 1,000 milligrams equals 1 gram. For this one, you don't need another one. Why? Because you're in the unit of grams. And for the last one, 10 decigrams equals 1 gram. You should have everything you need to set these up. Now, am I requiring you to do all of these? No. Do them until you feel like you've got it down. The answer keys are online. If I don't give you enough time today and you feel you need some more work, the answer keys are online. You could come and see me during home base one day. You could come see me in the morning or when we have work time one day. Ask me to go over 1 or 2 of them with you. Okay? For now, ladies and gentlemen, you have got the next 20 minutes to work on these. You want to go in the lab station, work as a big group, you're welcome to. You want to pull some desks together, work as a group, you're welcome to. Whatever you want to do, ladies and gentlemen. Okay? So, please go to work. You got 20 minutes to work on this, ladies and gentlemen. Then at the end of the hour, we are going to talk a little bit about accuracy and precision. I know, Jules, it's terrible me introducing new things to you, but that's what this class is all about. Okay, let's go to work. Go. Yes, sir.
I ended up doing a project last night, so I ended up getting a little bit of it.
Okay, hang on one second. Let me get my timer set. And I also want to, I'm not going to stop my video because if I do, I am going to forget to restart it. So, okay, here's the problem. This conversion here, okay? You use the one with the lowercase d instead of the upper. So if you, on my sheet, borrow your pencil, this should have been 10 decagrams. Oh, no, sorry, 1 decagram. So the good news, what you're doing here is perfect. The difference between the lowercase and the uppercase, hang on, I'm trying to get there, is this. Uppercase is deca, lowercase is deci. Sorry, I don't know why they did that, but they chose to do that using deca and deca. So that's the difference. Capital D is here, lowercase d is over here. Okay? So the good news, what you're doing is correct, you just grabbed the wrong one. Okay? Albert, any questions? I never give you anything. So now, once you get this here, 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 remember, this one, this one. It's those are the guys. That's what it is. This is one. You have multiple. Just multiply it together like that. And you divide by the 1,000 and then divide by 1,000 again. This becomes 5. Numbers are 5. This way, this is right here. So you put in your ID, red box, yes. Only when there's both of them. If they're both on the bottom, then you want to divide by both of them. If you have both sides together, you have to. You could use this one only by this, divided by this. On the bottom, then you don't know. It all depends on how you want to split the 2,000. But that's the math. Okay? You still don't get it, we open up.
We have not gotten into things yet, but that's okay. That's why not. Yes, it's okay. It's okay. That part we haven't got yet. As long as you're getting the right number, the right amount of zeros after, the right amount of zeros before, that's what we're worried about. Okay? Albert, you okay still? Okay. So for these, okay, we got this one done. Because this one, here's the one conversion of the middle, and this is the other. Okay? So that'll get you there. When you get to that, I don't give you any. Okay? But what we can do is take the conversion we know and shoot it. Okay? So we're going to take the conversion that we know. One decimeter is we're going to shoot the whole thing. So if you do that, this becomes what's one times one times one. EM2, the number that you do, right? Okay. What's 1,000? Now this is this. Well, again, I don't know cubic conversion. I don't know, but I do know that 10. I'm guessing the rate is 10. That's what I'm giving you. So, if I'm giving you this, but I'm telling you that the number that you see unit on both sides. So when you do that, now use this, with this unit, which is CM right? Try doing that. And then, okay? Very good. We're all, as long as I'm giving you a fact that you can cancel off the unit that you start with and get to the unit that you end with. Well, this will get you out of here into centimeters cubed, right? Well, then it's just like this problem. Centimeters cubed, you're going to use this one and then this one. Okay? So when you do this, what you're going to see is a progression. First, we went from milliliters to liters. Then we went from cubic centimeters to milliliters to liters. Here we went from these to this to this. So that one's going to have some stuff. So just try setting it up. If you get stuck, I'll come back over and give you a hand. Okay? Otherwise, you're well enough ahead to, we can talk about it. I'm going to go over it with everybody on Tuesday or next week, Wednesday. Okay. Yes. Remember that. Thank you, sir. Okay, you got a little under 7 minutes left, ladies and gentlemen. If you have questions, if there's something you need help with, make sure you call me over. Questions? Yes, yes, yes. If you look at my answer keys, and there's a number like 0.0001, and then there's a 0 after that, don't worry, as long as you get the 0.001. Okay? We'll talk about that other part today or next week, Monday, or next week, Tuesday and Wednesday. This is correct. Here, all we got to do is finish it. In all these problems, we can always there's going to be a lot of problems about it, right? So again, don't panic. Yeah. Oh man. Okay. Again, remember, this is the bottom. It's up, and then very simple. Easy. By the way, the one group has. In reality, we're on this type of conversion. Okay. But we're going to practice, so that's why you're getting some numbers that are slightly small or large or things like that. Normally, we would convert units and way more. And then natural, back then. Because we have problems with it or whatever. Okay. All right, wait, what do we got? Okay, well, will those units cancel? Cancel. Okay, so now you're in this unit, right? Well, if we want to get to liters, we need to use this. This is getting me out of here and into here, so how would we put that in? That you. Five. Correct. No. Centimeters cubed. Centimeter cubed. Both. On the test, maybe we have it. Okay, so what goes on the top? Good. These cancel. They cancel. So now if you stop, you'd be in milliliters, right? So we want to go to liters. So what's the next question? There you go. Just let the units walk you through the problem. What's that? Okay. This is the one that was harder than this one. Because this one, you started out, you get it. Right? Here you're inside of the street. These guys start. That's not here. Right? Yes. Nope, sorry. Oh. Remember to put the number and the unit. And that's the unit that you want to have. Good. Question? All right, ladies and gentlemen, if you would come on back to your seats, please. Take out your computers and log into your EISN real quick. All right. Okay, couple of things. Okay, couple of things. Seeing some really good things. Okay, working problems, getting them set up correct. Occasionally struggles with which one goes on the top and which one goes on the bottom. Units always have to cancel, ladies and gentlemen. Always have to cancel. And yes, you're getting some kind of unusual answers. Why? Because I'm just having you work through the process of canceling units and getting a number. We would never go to a number where we would want a bunch of zeros at the beginning, like 0.000 some number, or we would never want a number that was like 320,000 with 3 zeros at the end. That's why we use different units. But for this practice, we're doing it, okay? Please remember, be careful. When you make this into a unit conversion, meaning a fraction, one on the top and one on the bottom, make sure you write the correct number and the correct unit with it so that you can actually see the units cancel. I mean, literally crossing them out, okay? And here's the other thing. If it helps, you can think of this number, which we are beginning with, as being over 1. So now you see it's clearly on the top, and it's got to cancel with milligrams, which have to be clearly on the bottom, okay? So again, that's just something to consider that you may want to do. So now when I do my 1,000 milligrams, it has to go on the bottom. My 1 gram has to go on top, okay? Milligrams and milligrams have now canceled. My last step is 100 centigrams over 1 gram, okay? Why? So that grams and grams will cancel out, okay? Now we finish the problem by just doing the math. Taking this number, multiplying it by 100, then dividing it by 1,000. Okay? So again, that's the process that we are going through. And if you're getting this correct, but you're making simple mistakes like you accidentally switched the 100 onto the bottom for grams and put 1 centigram on the side, that is correctable stuff. You just have to learn to be a little bit more careful and take your time. Questions? All right. Awesome. Awesome, ladies and gentlemen. Okay? Please remember, on a test, on a quiz, I will give you these things. I will give you the conversions, okay? The metric conversions. After a while, you're going to learn how to convert from milliliters to liters, and you'll be able to do it in your head. And in second trimester, when you're asked to do that, you don't even have to show me it. You can do it in your head, okay? But we will get you there, all right? We will get you there. All right. So I am going into my EISN, ladies and gentlemen, and I am going into the following slides. Now, we've been through these, so let me skip ahead just a little bit. Please find this slide that says measurements at the top. I think it's like slide 28, but our numbers might be a little different. Am I close? Can you find it for me?
I think it might be 22.
22? Okay, can you go to slide 22, please, ladies and gentlemen? Everybody there? No? Okay, please find it. You do.
Student. Yeah, yes, that doesn't show up.
Okay, is it not showing up in Canvas?
No, it is showing up in Canvas. Just when I click on it, it says I don't have.
Okay. Did everybody else find theirs? It's not in Canvas?
Yeah.
It is or it is not? Okay. All right. Then, again, remember I told you I was learning about Canvas, ladies and gentlemen? All right. I might have done something that might have taken it away from you, so hang on a second here. Edit. Try please refreshing your screen and seeing if it's there now. Okay, then here's what I would like you to do. Please try going into your Google Drive. Okay. Again, I might have messed you up here and I may have to fix this, ladies and gentlemen. But go into your Google Drive and type in student, or let's see, hang on. I got to think of what I named it. Unit 1 Student EISN. Please try typing that in for yourself and see if it shows up in your Google Drive. Okay, you got to talk to me because I don't know. Did you find it that way?
Yeah.
Okay. So when you open it up, you're going to have to make a bookmark for it and you're going to have to save it for yourself because I accidentally took it away from you through Canvas. Okay? I made a mistake and I took it out of Canvas accidentally because I changed it to a non-graded thing, which must have taken it away from you in Canvas. So you're going to have to go into your Google Drive, do Unit 1 Student EISN, and click on it. Does everybody have it that way? Yes? We're good then? Okay, could you please get to slide 22 in that? I'm sorry about that, ladies and gentlemen. I won't make that mistake again, but I'm sorry I'm learning Canvas kind of just like you are, and I'm sorry about that, ladies and gentlemen. All right. Those are examples of 4 different measurements, ladies and gentlemen. 4.25 centimeters, 1.268 grams, 358 milliliters, 24 students. That measurement shows me 3 things. Name one thing that every one of those measurements shows. Numbers or quantity. Okay? So a number or a quantity. Okay? So all measurements show a number or a quantity. Name me something else that all of those show.
Units.
Units. Very good. Every one of them shows a unit. Now the third thing that every measurement shows is kind of hidden. Okay? But the third thing that every measurement shows is something called precision and uncertainty. Precision and uncertainty. Now, you guys cannot recognize precision and uncertainty now. Why? Because I haven't taught you about it. But as a scientist, I can look at that first number, 4.25 centimeters, and I can tell you what precision the instrument used to make that measurement had. Okay? By looking at a number, I could tell you what precision the instrument had. Now, really quickly, ladies and gentlemen. Are those 2 numbers the same or are they different? Same? Why? Okay, they're both 3.6, correct? And in math class, those would have the same value. However, in science, those numbers are different. Why? That 0 in the top number has meaning to someone in science. It may not to someone in math. So when you punch a number into your calculator and it gives you a bunch of zeros, those numbers may or may not have meaning in science. Okay? That is precision, that is uncertainty, ladies and gentlemen. And that's what we're going to get into talking to you about. How you can recognize, should I have this 0 there? Some of you were saying in your answer keys, Mr. Brand, you had a 0 at the end. Mine didn't have one. This is why mine had a 0 at the end. In science, that 0 means something. In math, it doesn't. Number-wise, value-wise, these two are the same. Precision-wise, they are not. Okay? So just so we understand, that's what we're going to start talking about a little bit. Okay? So the next slide in your notes that I want you to get to is the one that says accuracy and precision, please, ladies and gentlemen. So it's a section in there. If you go back to the second slide, there's a link that'll take you to this, or it should be around slide 20-some for you. I'm sorry that our numbers aren't matching up. Can someone find what slide that is and let the class know? 25? Thank you very much. Okay? All right. So you may have heard of these terms before, but probably not too familiar with them. When scientists make measurements, they measure or evaluate both the accuracy and the precision of a measurement. Okay? There are two different ways of looking at a measurement. Accuracy refers how close the measurement is to an accepted or a known value. That is what accuracy is. How close was the measurement to what it should be? Showed you this book yesterday. This is a book of targets. If you want to know what the boiling point of any element on the periodic table is, it's in here. You guys just Google it now. But if you were to go into Google and ask for the boiling point of mercury, it would tell you what temperature that is. So if you were to have some mercury in this class, which we're not allowed to have, but anyway, and you put a thermometer in there, and you look up on Google that the boiling point of mercury is supposed to be 1,316 degrees Celsius, and your thermometer is reading 1,300 degrees and your mercury is boiling, your thermometer is not very accurate. Why? It's supposed to be 1,316 degrees, you're boiling at 1,300 degrees. Well, probably a more practical example is water. Water is supposed to boil at 100 degrees, right? You put a thermometer in it, it's reading 98.7. Is your thermometer accurate? Not really. Accuracy is how close you come to a target. But the first thing you have to establish is a target. How many of you have ever shot archery? Okay? So Mr. Keene takes you out to shoot archery in Fayette, right? So I go out there and I'm going to show him what a great shot I am. So I pull back and I let it go, and that big round target, miss it completely. Am I accurate? Oh, yes, I am. Because Mr. Keene is laying behind it with an arrow in his butt. Did I tell you what I was aiming for? No. First thing you got to find out is, what were you aiming for? If you're not aiming for the center of the target, you can miss it completely and be okay. What's your target? What are you aiming for? Now, again, we're talking about the boiling point. There's only one target for that. We're talking about the density of something. There's only one target for that. Okay? Accuracy says how close did you come to hitting your target. Okay? The accepted value has to be looked up or found. You got to have Google, you got to have a book, you got to have something that tells you what the accepted value is. Or we could calculate it in class. So when we're doing experiments later on in the year, we're going to calculate how much stuff we should get, then do the experiment and determine how much we get. They may not be the same. Okay? They may not be the same. So examples of things that can be looked up: boiling point, density, melting point, freezing point, specific heat. The point is you have to have something to compare to. Okay? You have to have something to compare to. I'm going to put these things up there for precision because we've only got about a little over a minute left. Get them typed into your computer, and then that's it for the week, ladies and gentlemen. And I will start out class next week, Tuesday, with this slide up there if you don't get finished. But if you type, I don't know, if you type fairly quickly, you probably can get that done. So don't ask me to do it because I can't type very quickly. By the way, please remember, on Tuesday, ladies and gentlemen, we start keeping track of tardies. So if you are tardy and don't get to class on time, we start putting them into the computer for you, and I start talking to you about them, and we start getting our tally going if you're tardy. Also, a weird thing happened to me the other day, ladies and gentlemen. When I was helping a bunch of students out in my class later in the day, I noticed that a lot of people, like in the back, had their phones sitting on their laps. Boy, I hope I don't ever see that, because if I do, again, if I see your cell phone out after I've warned you, I'm going to ask you to put it in the box. So please don't make me do that. Have a great day, ladies and gentlemen. We will see you Tuesday. Enjoy your 4-day weekend.
Have a good weekend.
Thank you.